So let's start. Okay. So to understand hybridization concept and bonding between the chemicals, first we have to understand what we mean by bonding. Okay, so we know that when a group of atom exists together and possesses some characteristics, then we call it as a molecule. If a group of atom is existing together, means there will be some force of attraction between them. Now that force of attraction is nothing called the chemical bond. Okay, so the definition of chemical bond can be the force of attraction which held together the atoms within a molecule is called our chemical bonding. Okay, now chemical bondings are two types. Okay, generally we have two types of bond. Okay, chemical bonds are two types. Okay, one is ionic bond. Okay, the other one is covalent bond. Okay, the first one is ionic bond and the second one is covalent bond. See, to understand hybridization, first we have to understand the basics of chemical bonds, or how many types of bonds are there, what are their characteristics. Okay, what is ionic bond, what is covalent bond. Okay, after knowing that only we can go for the complete details about hybridization. Okay, so what do you mean by ionic bond? So from class 9th onwards we studied that ionic bonds are formed when there is a complete transfer of electron. Okay, so the definition of ionic bond will be the ionic bonds are those bond. Okay, ionic bonds are those bond where electrons are completely transferred from one atom to the other. Okay, so here complete transfer of electron takes place. Complete transfer of electron takes place. Okay, example we can take NaCl. Okay, sodium donate one of its electron to chlorine, and chlorine accept one of the electron from sodium, and they form a what? Ionic bond. So the definition of ionic bond will be the bond formed by the complete transfer of one or more electron from one atom to the other atom. Okay, so this is about ionic bond. Similarly, what is covalent bond? Covalent bonds are formed by sharing of electron. Okay, covalent bond is formed by sharing of electron. Sharing of electron. Okay, so ionic bond is complete transfer, means one will donate, another one will accept. But in case of covalent bond, what happens? Sharing of electron takes place, means both the atoms share their electron. Now this sharing of electron takes place in two ways. Okay, this sharing takes place in two ways. The first way is that when the shared pair of electron are contributed by both the atom equally, then that type of bond formed is called covalent bond. Okay, covalent bond. For example, H2, O2, N2. Okay, here both the atoms share their electron to each other. Means here the shared pair of electron are contributed by both the atom. But when the shared pair of electron are contributed entirely by one atom but shared by both, then that type of bond is called coordinate bond. Coordinate bond, or we say it as a dative bond. Dative bond. Clear? So this I am not going deep into this because we have to focus on the topic hybridization. So the basic thing I am saying, that is the ionic bond. What is meant by ionic bond? Ionic bonds are those bonds which are formed by complete transfer of electron, whereas covalent bonds are those bonds which are formed when there is a sharing of electron, and that sharing of electrons also takes place in two ways. One is when the shared pair of electron are contributed by both the atom equally, then that time the bond formed is called covalent bond, where The shade paid of electron is contributed entirely by one atom, but shared by both. Then that type of bond formed is called covalent bond. In detail, what is covalent coordinate bond? So in detail, what is coordinate bond? In detail, we will discuss it further. Okay, so this is the basic of ionic bond and covalent bond. So there are so many theories came into existence that to explain covalent bond. Okay, just like our Lewis approach towards the covalent bond, VSCPR theory, valence bond theory, hybridization, molecular orbital theory. So out of all the theories, so today we are going to focus on the topic that is called hybridization. Okay. So hybridization means the basic things that come to our mind is something hybridized. Okay, some hybrid thing we are going to get. Okay, for example, if we take an example of muel. Okay, so what is muel? Muel is a what? Hybrid of horse and donkey. Similarly, another example I would like to give. We want two tone of pink color. Okay, but we have one not tone, just take it as a tank. Okay, one tank, two tank of pink color, but we have one tank of white color and one tank of red color. So what we can do, we can intermix what white color and red color in order to get pink color. So there what happens, we have mixed two things to get a new thing. The hybridization concept is exactly the same. So what is hybridization? Okay, let me write the definition. So while I write, you can also note it down in your notes. Okay, so hybridization is defined as intermixing of atomic orbital. Okay, intermixing of atomic orbital belonging to the same atom but slightly different in energy, so that redistribution of energy takes place, resulting in the formation of new orbital of equal energy and identical shape and size. Okay, so this will be the definition of hybridization. Okay, once again I am reading. Hybridization is defined as the intermixing of atomic orbital. Means we have to mix the atomic orbital. So what we do during hybridization, we mix the atomic orbital. Here one very important line, that is belonging to the same atom. Okay, so the orbitals should be of same atom but slightly different in energy. Means their energy must be slightly different, or we can say nearly equal energy, so that redistribution of energy takes place. Redistribution means the energy is redistributed in resulting what? In the formation of a new orbital. Okay, in result what we get? A new orbital. That new orbital have equal energy and identical shape and size. Okay, this is the definition of hybridization, or if simple words, if you want to remember, you can say that hybridization is nothing but it is a process of intermixing of atomic orbital belonging to the same atom in order to get a new set of orbitals, okay, a new set of orbitals having equal energy, equal shape and equal size. Okay, now the new set of orbitals which are produced, that is nothing but that is called hybrid orbitals, and the whole process is known as hybridization. Clear everyone? Okay, so now why hybridization concept came? Okay, we have to understand that as well. Okay, we have so many theories. Valence bond theory means mostly we know that what a covalent bond is formed by overlapping of orbital. Then why this hybridization concept came into existence? Okay, so to understand that, we will take an example, that is the formation of CH4 molecule. By taking that example, we will understand why hybridization came into existence. Okay, so we all know that what valence bond theory, according to valence bond theory, how the bond is formed? By overlapping of half-filled orbitals. Okay, valence half-filled orbitals. So let me write here molecule, that is CH4. Okay, here what is the, which one is the central metal atom? Carbon is the central metal atom. So let me write here, carbon is the central metal atom. So how many hydrogen is attached to that? 4 hydrogen are attached to that. Okay, so carbon forms 4 hydrogen, carbon forms 4 bond with what? Hydrogen. Which bond? That is sigma bond. Okay, chalo. So let's see, carbon with atomic number 6, electronic configuration 1s2, 2s2, 2p2. Okay, so as I told, valence bond theory concept, that is the overlapping of half-filled orbital takes place. Now here, which one is the valence cell? Second cell is the valence cell. What we mean by valence cell? The last cell is called our valence cell. So here with valence cell is 2. So here s orbital consists of how many electrons? 2 electrons. P orbital consists of how many electrons? 2 electrons. So if we see here, focus here, how many half-filled orbitals are there? 2. Okay, this and this half-filled orbitals, but carbon is forming bond with 4 hydrogen, means it requires 4 hybrid orbitals. Okay, so now during excitation, okay, see this star means that carbon is excited. Okay, so during excitation, carbon's 1 electron jump from lower energy level to higher energy level, means 1 electron from the 2s jump from s to p. Okay, so the electronic configuration will be 2s 1 and 2p 3. Okay, so here now s consists of 1 electron. Now p orbital consists of 3 electron. Now as a total, how many half-filled orbitals is the rest? 4. Now it can easily form bond with 4 hydrogen. So let me write here. First hydrogen with atomic number 1, electronic configuration 1s1 with 1 half-filled orbital. Similarly, the second hydrogen 1s1 with 1 half-filled orbital. Okay, that is the s orbital. Then the third hydrogen 1s1 with 1 electron. Then the fourth hydrogen 1s1 with 1 electron. Now hydrogen has 4 half-filled orbital, carbon has 4 half-filled orbital. Now easily they can what? Overlap and form a bond. Okay, now one thing. Here if you focus carefully, we can find that all the 4 overlappings are not similar. Okay, 3 overlapping. See, this overlapping is S and P. Okay, let me write here the name. This is PX, PY, PZ. Okay, and this one is S orbit. Here everyone are S. So here 3 overlappings. See, focus to me. These 3 orbitals are what? S, P overlapping. Okay, and this one overlapping is S overlapping. So out of 4 bonds, okay, out of 4 bonds of carbon, one bond is formed by the overlapping of S and S. Hydrogen's S orbital and carbon's S orbital. Okay, and the other 3 bond are formed by overlapping of S and P. One S of hydrogen and one P of carbon. One S of third hydrogen and one P of carbon, and one S of fourth hydrogen and P of carbon. Okay, so one overlapping is different from 3. So if we think it theoretically, then the what bonding, one bond should be different, right? So if we go for the structure, okay, so if we go for the structure, carbon one bond is different. So let me take this as a px. Okay, px to px. Okay, and this is 2p1, and this is 2pz. Clear? This is 2pz. All have one unpaired electron. Okay, S also has one unpaired electron. So let me do here. This is S. Okay, one unpaired electron. Now when hydrogen approaches all the 4 half-filled orbitals, that is the S orbital of all the 4 hydrogen atom overlap. So the overlapping will be like this. Because S orbital is overlapping, so the shape will be spherical. Okay, these all are the S orbitals of what? Hydrogen atom. These are the S orbital of hydrogen atom. Okay, so now you see one bond, one overlapping is different. These 3 overlapping is between S and P. Clear? S and P. But one overlapping is in between S and S. So theoretically when we think, okay, so one bond should be different. Okay, but experimentally we find that carbons, all the 4 bonds formed are equal. Then how is it possible? Okay, so to overcome this circumstance, okay, hybridization concept came. So now what is meant by hybridization? So what we have to do so that all the orbitals will be equal. See, here 3 orbitals are equal. One orbital is, means one overlapping is different. So what we should do that all the 4 overlapping will be same. Intermix the orbital. So as I told, hybridization is nothing but intermixing the orbitals. So we will do also that only. But we will intermix the orbital of carbon, because carbon only creating a problem, because hydrogens all the orbitals are same, but in case of carbon, what, one orbital is getting different. So here what we will do, we will mix all the 4 orbitals of carbon, okay, so that we will get a new hybrid orbitals. When after forming hybrid orbitals, when they overlap, all the 4 bonds will be same. So let's see how. See, one S orbital, okay, then 3 P orbitals. Okay, let me mention here Px, Py and Pj. Okay, you can simply write also P. Okay, all have one unpaired electron. Clear? So now what we will do? We will intermix the orbitals, atomic orbitals of carbon, in order to get what? A new hybrid orbital which will be having equal energy, equal shape and equal size. So after forming that, there will be no problem. Okay. So here when we intermix, how many atomic orbitals we have intermixed? 1 S and 3 P orbital. So in result also we will get what? 4 hybrid orbital. Okay, and that hybrid orbital is, the shape is like this, means one is smaller lobe, another one is larger lobe. Say how many? Smaller lobe, larger lobe. Smaller, larger. Smaller, larger. Clear? So in result, how many orbitals we got? 4 hybrid orbitals. Why these are called hybrid orbitals? Because after hybridization, we got these orbitals which have nearly equal energy, equal shape. See, energy is equal, shape is also equal. Okay, so what is its name? Its name will be sp3. Why its name is sp3? Because 1 s orbital and 3 p orbitals are intermixed. So its name will be sp3. So all the 4 hybrid orbitals name is sp3. Clear up to here? Now each hybrid orbital is having now what? 1 unpaired electron. Now when we go for hydrogen, each hydrogen is having how many electrons? 1s1 with 1 electron. Now the overlapping can take place or not? Yes. Similarly here another hydrogen is also 1s1 with 1 unpaired electron in its half filled orbital. Now this overlapping will take place. Similarly another hydrogens 1 electron overlapping takes place. Okay, similarly fourth hydrogens 1 unpaired electron overlapping takes place. Now when you focus here, the overlapping is between S and sp3. Now is there any overlapping different? No. But here one overlapping was different, that is SS overlapping. But in case of after hybridization, all the 4 overlappings are same. Okay. Now to overcome this, hybridization concept came into existence. Clear everyone? Okay. Now for hybridization we require, okay, in detail what is its structure, what is its bond angle, we will see further, okay, when we go for different types of hybridization. So this I have explained just to understand why hybridization came into existence. Okay. So to do something we require, there is some conditions, okay. So here also for hybridization we have so many conditions, okay. So let's discuss about that. So our topic will be some important conditions for hybridization. Okay. Important conditions for hybridization. Okay. So listen. So the very first important condition is that, okay, the only those orbitals can participate in the hybridization which have nearly equal energy. Okay. So the first condition is that orbital, okay, I am writing it shortly. Orbitals having approximate energy. Okay, orbitals which have approximate energy, and one more important, belonging to the same atom. Belonging to the same atom. So the very first condition that is required for hybridization is the atomic orbital must have nearly equal energy or approximate energy so that they can participate in the hybridization. Okay, so the first condition is that only those orbital can participate in the hybridization which possesses nearly equal energy or approximately energy. Clear? Okay. Now the second condition is that only those orbitals which are present in the valence shell can only participate in the hybridization. Means we can write here valence orbital takes part in the hybridization. Okay, only those orbitals which are present in the valence shell, because all the concept comes, that is only what, valence shell. Only the valence shell participate in the what, hybridization. So the orbitals which are present in the valence shell participate in the hybridization. Okay, then the third important condition is that promotion of electron is not necessary. Okay, I am writing here, then after I will explain you. Promotion of electron is not necessary prior to hybridization. Okay, so I'm giving you 1 minute, you can note it down. Okay, so promotion of electron is not necessary prior to hybridization. What is this promotion of electron? Promotion means what? One step higher. Okay, so when we have see, last we have seen that hybridization of CH4. Okay, one electron were jumping from s orbital to p orbital in order to form 4 half-filled orbital, right? So promotion of electron is not necessary. It is not necessary for all the molecule. Okay, clear? There are some molecule where promotion of electron is not required. They simply stay as a or act as a lone pair in that particular molecule. Okay, for example, we will take NHA3. Okay, so I think you have written. So when we take example, that is what? NHA3. Okay, here. Okay, so this dot, two dots means there is a pair of electron. Okay, nitrogen, atomic number is 7. Electronic configuration 1s2, 2s2, 2p3. Okay, now which one is the valence cell? Second cell is the valence cell. How many orbitals present in the valence cell? S and p. In s orbital there is 2 electrons, and in p orbital there are 3 electrons. Clear? Similarly, here how many hydrogen are approaching? 3 hydrogens are approaching. Each hydrogen with one electron. This orbital S orbital form bond. Okay, so here this promotion of electron is not required. Okay, this electron is not transmitted from S to P or further up is higher atomic or energy level. Clear? So sometimes the extra the electron remains or act as a lone pair of electron. Clear? So the third condition was promotion of electron is not necessary prior to hybridization. Clear? Now similarly the last or fourth condition is that, see, not all the half-filled orbital, it is not necessary that all the half-filled orbital participate in the what? Hybridization. In the same way, not only hybrid orbitals participate in the not all the hybrid orbitals participate in the hybridization. Not hybrid orbitals, half-filled orbitals. Okay, not all the half-filled orbitals participate in the hybridization. Okay, not only hybrid orbitals participate in the hybridization. There are some orbitals, fully filled orbitals, that also participate in the hybridization. But the thing is that we have to promote an electron in order to get half-filled, because the valence bond theory concept is all about what? Overlapping of half-filled orbital. Clear? So these were the conditions for hybridization. Now let's see what are the features of hybridization. Okay. So the next thing will be our features of hybridization. Features of okay, means what are the features of hybridization? Okay, the first feature is that number of hybrid orbitals obtained. Okay, I am writing here shortly. Number of hybrid orbitals is equal to number of atomic orbital mixed. Okay, so the very first feature is that number of hybrid orbitals you get is always equals to the number of atomic orbital you have intermixed. Suppose is the first example I have given, we want 2 tank of pink color, but we have 1 tank of white color and 1 tank of red color. So when I am mixing 1 tank of white color and 1 tank of red color, okay, so 1 tank, in result what we are getting, 2 tank of pink color. So similarly, if we are mixing 2 atomic orbital, for example, if we are mixing 1 s with 1 p, in result how many we will get, how many hybrid orbitals we will get, 2 sp hybrid orbitals we will get. Okay, if you are not understanding, I am writing like this, sp and sp. This means 2 hybrid orbitals we are getting. Similarly, if we are mixing 1 s orbital with 2 p orbital, okay, because we know p sub cell has how many orbitals, 3 orbitals. Okay, out of 3 we are intermixing 2. In result, how many atomic orbitals we have mixed? 1, 2, 3. So in result, how many orbitals, hybrid orbitals we will get? 3. Okay, sp2, sp2, sp2. Okay, so if we are mixing 3, we will get 3 hybrid orbitals. If we are intermixing 2, in result we will get 2 hybrid orbitals. If we are intermixing 4, 1s and 3 p orbital, in order we will get what? 4 sp3, sp3, sp3 and sp3. Okay, so this is the first feature of sorry, this is the first feature of what? Hybridization is that number of atomic orbital you are intermixing, that many numbers of hybrid orbitals you will be getting. Clear? Now, the second feature is that the orbitals which are intermixed must have what? Nearly equal energy. We have read in the condition. So the feature will be what? The hybrid orbitals which are formed. The hybrid orbitals which are formed have equal energy, equal shape and equal size. Because the hybridization concept is only that you should intermix two atomic orbital which have nearly different energy or slightly equal energy in order to get a set of new hybrid orbitals where the orbital's energy will be equal. Its shape will be identical. Size will be also same. Okay. So the second feature is that the hybrid orbitals produced have equal energy, are identical in shape and size. Okay. The second feature is the hybrid orbitals which are produced have equal energy, identical in shape and size, as we have also seen in case of CH4. Okay, the hybrid orbitals, all the 4 hybrid orbitals formed, that is having equal energy, equal shape and equal size. Clear? So these two are the features of what? Hybridization. Similarly, another feature is that as I told, the hybrid orbital is denoted with a smaller lobe and a larger lobe. Okay, the thing we have to remember is that the smaller lobe is always denoted by a negative sign. Okay, and the larger lobe is always represented by a positive sign. Okay, clear? These were the some basic features of what? Hybridization. So what we have learned today? So first we have seen what is ionic bond, what is covalent bond. Okay, then what is the definition of hybridization, or why the hybridization concept came into existence. Okay, then we have seen the conditions that is required for hybridization, and then we have seen the features of hybridization. Okay, so next we will see the variety varieties of hybridization, or what are the types of hybridization. Okay, so we have so many orbitals like s orbital, p orbital, d orbital. Okay, so the hybridization will be also variety types. Okay, if we are mixing one s and one p, it will be sp hybridization. If you are intermixing one s and two p, then we are getting sp2 hybridization. Okay, similarly we have sp3 hybridization, sp3 DA hybridization, because d orbital is also introduced. Okay, then sp3 d2, sp3 d3, because d subcell we have five orbitals. Okay, so we have so many types of hybridization. So in the next class we will be discussing about types of hybridization. Okay, so if you like my video, please like, share and subscribe. Okay, thank you.